so the idea today is to speak, so as I say, about haptic technology. So myself, it's Pierre Como from Actronika. I am the CEO. And at Actronika, we develop haptic feedback. So we have developed haptic technology because most of the time we're using our haptic technology in customer products. So it could be for a mouse, a keyboard, a toys, thing like that. But why I'm here today is because of the product I'm wearing right now. It's a haptic vest. And so the idea is to enhance your VR experiences, to bring the sense of touch in those experiences. So to give you a brief background about the haptics. So the haptics is the science of touch, and more generally the communication through the sense of touch. So for the sense of touch, there is different way to give this type of feedback. So you can give it with temperature, you can give it with movement, like my hands cannot go through this table. It's because of one part of my sense of touch. And there is also the vibrotactile haptics. So it's mainly about when you explore a surface. Here I can feel it's different. It's because there is some small vibrations that occur on my hand. And so the idea with what we do here, it's to generate this type of vibration to simulate your sense of touch. So the presentation here will be mainly about VR and so how the sense of touch is bring to VR, and so a brief history about that. Also, what is important to have the sense of touch in your VR experiences. And after I will go deeper about this product, how it works, and what is the difference compared to our competitors. So I suppose all of you may know the virtual reality. It's very old science. But there is a major turning with the headset you can have at your home right now. But still, there is still something missing with it. Is the sense of touch. So as I say, maybe we didn't think about it, but our sense of touch it's really important. All the time when you are sitting on a seat, you are using your sense of touch. When you are wearing something, you are using your sense of touch. And so when you are developing VR experiences without the sense of touch, you're missing all that. So it's really important to trying to bring it. But obviously, as I say, on Actronika side, we are focusing only on the vibrotactile feedback. So we are missing all the temperature feedback or the kinesthetic feedback or things like that. So, but what we can see is that we can create illusion for the brain as we do it for the visual or for the hearing. So for the sense of touch, we don't need to reproduce all the aspects of it, and focusing only on the vibrotactile feedback could be enough. So about the vest kinetic, so it's a vest that is limited only to the torso. So in terms of experiences, it can be limited only to interaction with your upper body. But what we could provide as well, it's, as I say, Actronika, we are providing a haptic technology. So we are able to provide to you only vibrators and the hardware, and you can install it in every type of devices. So if you want to develop a gloves, if you want to develop a pants, for instance, you can do it. In fact, all the software solution we have developed will be compatible if you want to do it in another type of device. So now if we go deeper on how it works, I don't know, maybe if you have some experiences with haptic feedback in VR, maybe you are aware of bHaptics, for instance. It's a Korean company. But in terms of the type of feedback they are providing, it's completely different. So here we compare these two solutions. So what you have on the left is the type of vibrator or actuators you can find in your controller, like the one in the PS4 or something like that. So it's very basic eccentric rotary motors. And one of the main disadvantages of the solution is the fact that you cannot control separately the amplitude and the frequency in the signal you are generated with it. On the opposite, the high voice coil motor, so on the right, is the type of actuator we are using with this vest. And here you can fully control the frequency and the amplitude separately. Obviously, there is a cost with that, is the fact that in terms of consumption is less efficient than the ERM actuator. But it means if you are able to fully control separately the frequency and the amplitude, you can do very sharp effects. You can also have a very low latency reaction. So here you can see on the left, so we compare these two technology, and if we try to send a sine wave and we want to change the frequency very brutally, with a voice coil motor, you are able to do it, but with the other solutions, it's not possible. You need to allow some time to change the frequency. And in the same manner, if you want to do some impulsional effects, it will almost not be possible to do it with eccentric rotary motors, because as you can guess it can take time to begin to have the rotation put in place, and so it's not possible to do it. So the fact to use voice coil motors, what it's allowed to do with our haptic vests is the fact that you can have a full specialization capabilities. So mainly is the fact that you can on one way to have only a lot of impulsion on different places of the on the vest, for instance. So if you want to do a rain effect for you can do it. And on the other way, if you want to do some continuous motion, so for instance, if you want to simulate a caress or a massage or something like that, you can do it as well. And it's very interesting because it means that you can give the feeling that something touching you between two actuators. You can, give this movement going, and even if there is no actuator in this area, you can have feeling. And so it means that the limit, there is no limitation in terms of effects you can create with it. So it's really only limited by your imagination. Here it's only a short list, an instance of what you can do, and you can test as well. And in the expo downstairs, we have a demo where you can test rain, as I say, you can test wind, gunshots, so a lot of different effects. But also, it can seem very difficult to understand this type of effects, because if you have there is no limitation in terms of effect you can create, and there is a full capability in terms of specialization, you can think that maybe it will be hard to integrate in your experiences. But in fact, it's something that we had in mind at Actronika, was to develop also a set of tools to allow you to easily integrate those effects in your experiences. So we have developed, first of all, a Unitouch engine. So it's a software with a plugin for Unity and Unreal Engine. And as well, we can provide to you an SDK in C++ or C# to allow you to easily integrate, as I say, effects in your game. Besides, we have also, because when I mentioned winds, fire, stuff like that, you can also ask yourself how you will create these effects. What is the fire feeling? What is the winds feeling? So the idea was, again, to facilitate your life. So we have a library of effects. So again, if you want to design for the next 3 days to add haptic in your experiences, we could provide to you a whole set of effects, and you can download them and play them in your experience. And also, if you also have the feeling that you could design by yourself some effects, we will provide a designer, so it will not be available for this hackathon, but it's something that we will provide to our customers after. So it will be my last slide. So it's about this product. So we have launched a Kickstarter yesterday, in fact, and the idea is for Actronika to finish the industrialization of this product by the end of the year, and hopefully maybe to have something back from you during the next 3 days to maybe try to improve the product before that. So thank you for your time. If you have maybe any question, I'm here to answer them. So yeah, thank you. How many sensors are currently on the suit? So on the suit, there's 20 actuators. So there is 4 big ones, 4 like this, and 16 smaller. What's the weight? So it's 1.8 kilogram. Also, what I didn't mention, it's a wired version that I have here for the moment. So you have 2 cables. So we have a cable for the power and one for the data, but we will also provide a wireless version of it. Yeah.
How do you translate the treatment to the best? Is there like algorithm, or you just calculate like I don't know? How do you make it feel real?
Yeah. Okay. So there is different strategy to design an effects. The one solution is to measure the effects. So I have another demo also downstairs where there is a cup and we put balls in it. We put grapes. We put rice, things like that. And here we measure it and we do full treatment on the data, and after we reproduce them. And for instance, for the rain effects, it's completely a design from scratch. It's just to think about what it is and just to try it, and it's like sound design or something like that, you know. Okay. The range of our actuator is between 30 Hz to 500 Hz. It's what we consider for the haptic feedback, but in fact, it can go higher than that. We can go up to 2 kilohertz, but for the haptics, it's not really relevant, but this could be relevant to generate sound because it's allowed to increase the immersion if you can generate the same song and the one you expect with when there is, as when I do that, there is a sound. So if you can keep it, it's relevant to do it. Okay, so thank you very much. Thank you.